Boom.
He's Monaco.
And that's Milks.
Yes, you are.
There you go.
Back for lecture 6.
Matter, the properties, changes, and separation. This particular lecture is going to be quick, but it is the foundation of what chemists kind of do on a daily basis if you go get a job as a chemist and actually work in a lab or plant or factory where you're doing chemistry. This is a lot of the stuff that
I believe that some of this stuff is testable. This physical changes, chemical changes stuff is testable.
Mm-hmm.
And the separation, how do I separate certain things, is
very important.
Very testable. So
very important and testable.
We want to pay attention. And first, let's do our
learning target.
Today, you will be able to distinguish between physical and chemical properties as well as physical and chemical changes.
The properties and changes are not the same as.
No, they're not.
Mm-hmm.
But
they're related and important.
That's okay. You start.
Sure. You've got physical properties first. These are constants, and some examples are melting point, color, and texture.
Right.
Sure.
So yeah, it's like this tabletop is black
and it's hard.
Those are physical properties.
There you go.
Okay. Now, physical changes are when a change that doesn't alter the chemical properties of the substance, but you still got the same stuff. So like if I take a piece of paper, and I'm not going to tear this, but if I tore this,
it would still be paper.
Both parts would still be paper. So that would be a physical change.
The density of each didn't change?
No.
Okay.
Physical change.
No. So chemical properties are the behaviors that substances adhere to when I start doing reactions.
Right.
Do I release energy? Do I take in energy? Those kind of things.
Like water puts out fires.
Okay.
That's kind of a chemical property.
Kind of.
All water puts out fires.
Okay.
Right? Like if you put something other than water on a fire, the fire might not go out.
Depends on what kind of fire.
Depends on what kind of fire, but he's getting technical on me.
Well, yeah, but you don't put that on an electrical fire, I'm just saying.
Okay, good get.
Okay, got him.
You got it.
Moving on. Chemical changes, go.
Sure. Chemical changes is when a change happens and the substance is totally different now. So if you were to have some wood rotting, you can't turn that back. Or if you're lighting a fire.
Do it. Fire. Yeah. Oh, yeah. Sweet, man. All right.
Oh, I'm kind of cool.
Well,
but look. See right there? See, there's ash.
That's not paper anymore.
Yeah, this is. See that? That's not paper anymore.
No. It was paper.
Not anymore.
So this was a chemical change.
And here's how we know. Ready? Can I take the ash and turn it back into paper?
No.
Here, put that out before we get in trouble.
We're good.
Just do it.
We're good. All right. See, water puts out fires. I said it for a reason.
See? What water puts out Monaco's fires?
I don't do electrical fires.
Anyways, testable. Rusting and burning. And rusting is honestly the one that's going to show up on the test. And we'll learn it's an oxidation process later on. But rusting is a go in. That is no longer iron.
But in all seriousness, Milks mentioned something. If it's not the same afterwards, it's a chemical change. These are not really reversible.
Yeah, we can't go backwards.
I could glue the paper back together, but I can't turn the ash and smoke back into paper.
Correct. Now let's talk about separation techniques.
Yeah.
This first one is very common.
Yeah, you do it every morning when you're making hot brown.
Yeah, the coffee. Think of the coffee filter. There's that word, filter. And it doesn't let the coffee grounds down into the pot.
No, but the water dissolves some of the flavor and other chemical compounds that are soluble, and they travel through, and we call that the filtrate. So you see Milks walking around slamming coffee, he's really just drinking Filtrate.
He said filtrate. So again, solubility means will or will not dissolve, right? And sand will not dissolve. Therefore, I can filter it out.
Yep.
Right? So it's too large to go through the paper.
Just like the coffee ground.
Ready? Okay.
Next up, we've got evaporation. So one example is that you have salt and water. Salt is going to dissolve in the water, so you can't use filtration like we said before. So here you can heat up that mixture and the water will evaporate off, and then you have the salt left over.
Precisely.
Perfect. The only thing with this, with the picture and the word that doesn't jive, Evaporation really refers to the gradient difference in humidity. So if you put water out, I can let it evaporate over 7 days,
Okay.
right?
Yeah.
And this is just a forced boiling evaporation, right?
Right.
So just so we're clear.
You know your towel dries out overnight. The water evaporates out of it. But if you put it in the dryer and heat it up, it happens faster.
So
and that's
this
what
is
we're
just a
talking about. We're
forced
forcing it to go
just
faster.
forcing it. Yep, that's it. I just want to make sure it's
water evaporates.
That's one of those
Summer
words, man. It's one of those words. Got
Man.
multiple meetings, man.
Ooh, my favorite.
Ooh, I'm gonna let you do this one because you have this. You have the apparatus, and I don't. So
Oh, good. I love distillations. This is when we have two different liquids of different boiling points. So two fundamentally different substances that were pure but have been mixed. So like water and alcohol. Okay.
Sure.
And when you heat it up to a certain point, one of the liquids, which has the lower boiling point, will boil first, while the other one, which is not hot enough to boil yet, stays as a liquid.
Yep.
So the liquid that is boiled off is cooled and collected in this tube called a condensation column. Okay, it's
So-
this long. So that's your mixture right in there.
I got red,
Okay, Milks is drawn
and
on
I got
board.
blue.
Red and blue showing two different liquids in there,
And then the red's gonna kind of come up.
and condense down the tube and drip, 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 drip into the distilled liquid bottle. And now you have just pure red, and the blue or other liquid with the higher boiling point stays behind.
There we go.
I very much hope to do this in my class.
I think you will.
Mm-hmm.
I think you will. And then review of living environment. This is paper chromatography.
Mm-hmm.
Looks a lot like what you guys actually did with taking the paper and putting it down in the liquid. So this is just a separation technique based on the size of the components, the polarity of the components, the magnetism of the components. Paper specifically is size. So it's going to run up, short one. The big molecules are going to go shorter. The small molecules are going to go farther and
Right.
separate out right on the paper.
A lot like how Earth Science Connection sediments, when traveling in a river and they meet a larger body of water, the water slows down, so the large rocks and boulders fall out first. The smaller sediments go out further into the lake. So it's very much like that, in the much that when you dip your chromatography paper into the solvent, the big molecules kind of get stuck in the paper, can't go very far. The small ones move further out.
Wow. So we're clear. You just made an earth science reference. First time ever. Earth
Sorry,
science
bro.
reference. It's all right.
I'm just wavy.
See ya.
Bro, where's the button to click and turn off the video?